All right, guys, section 1.4, we're going to do a quick review of global or absolute mins and maxes and local or relative mins and maxes. So I've got a graph over here. And on this graph, we've got a starting point right here. There's no arrow. We've got a starting point. But there is an arrow on this side, so the graph is going right and down forever. So first question, we're looking for the global or the absolute maximum. Now, the global or the absolute min or max, these are always going to be y coordinates. Y coordinates. So to look for this, we're just going to, again, for the maximum, we're going to go to the highest point on the graph. And for the minimum, we're looking at the lowest point on the graph here. And so our highest point is right up here. But again, we're just giving the y coordinate when we look for the absolute min or max. So our maximum here is going to be 2. There is no absolute minimum for this graph because this graph moves right and down forever. And so the bottom point would be down at negative infinity. Now, local or relative maximums, these can occur at 2 places. They can occur at turning points. So right here, this would be a relative maximum because close to this point, it's above everything. Close to this point, again, ignoring the stuff over here. Close to the point, that point is above everything, so it's a maximum. But it can also occur at endpoints. And so this point is above everything that's close to it. And so this is also a local or relative maximum. Now, unlike the global or the absolute where we just give the y coordinates, here we're looking at giving the full coordinate point, or sometimes even just the x coordinate for the local or relative mins and maxes. The last one is the local or relative minimum. Well, that's going to be at a turning point. It's going to be right here because close to this, if I cover up the rest or even just erase some of it, right? If I get rid of everything that's not close to it, right? So this is below everything else that is close to it. So relative to this point, it is a minimum, even though it was the lowest point on the entire graph. Now, the next thing to remember here is the difference between even degree versus odd degree functions. Remember, if it's in standard form, it's just the biggest exponent. Okay, so the degree here is 4, the degree here is 6, the degree is 3, and the degree is 5. So if we've got an even degree function with a positive leading coefficient, remember the leading coefficient tells us which way the graph ends. So because this is a positive 7, the graph is going to end up to the right, like this. Even degree functions, the end behavior is the same on both sides, so it's going to start also up. If the graph ends up, it starts up for an even degree. Now, negative leading coefficient, what's going to happen with an even degree? So the negative leading coefficient tells us it ends down to the right. The even degree tells us it's going to start the same direction, so it's going to start down to the left right here. So notice both of these functions, this one has an absolute minimum, right? This one has an absolute minimum. This one has an absolute maximum right here. Now, for odd degree functions, they're not going to have, they might have a relative minimum. They're not going to have an absolute min or max. So odd degree, positive leading coefficient, ends up to the right. But odd degree means they go opposite directions. So if it's up to the right, then the graph is down to the left. Okay, in the middle, it could do anything. It doesn't have to just, it could, go up and down, up. So there could be relative minimums, but there's no absolute min or max. It goes up forever, down forever. Okay, odd degree is almost the same, or negative leading coefficient is almost the same. It's going to finish down to the right. And then because it's an odd degree, it's going to start the opposite direction up to the left. All right, so that's just a couple quick reminders. You guys should be able to do the practice now. And then again, we'll go over all of this coming Monday once you guys have had a chance to actually go over everything.